All right, everyone, we have arrived at our goal, and what we are trying to do is to determine if there is a relationship between two categorical variables. Let's go over and look at page 6 at the concept of a conditional distribution. All right, this says determining relationships between categorical variables. So what we're going to do to help us figure out if there is a relationship is we are going to use percents to help us determine if there's a relationship. Okay, we will often make conditional distributions based on the explanatory variable. These conditions can be made, which is what we're going to do, or they can be plainly seen in segmented. That's not how you spell segmented. Segmented bar graphs and mosaic plots. So that's part of the reason we were looking at segmented bar charts and graphs and why we were looking at mosaic plots, because these conditional distributions, we'll just be able to see them there. But a lot of times we're also going to be asked to make them, and that's what we're going to get into here in a little bit. So what is a conditional distribution? Well, they are going to be broken down into percents that are going to meet some sort of required condition. One of the things is that all the percents should add to 100%, and all the denominators should be the same. And you'll see what I'm talking about here in 1 second. If you create a conditional distribution and things are similar, then there is no relationship between the two variables that you're looking at. But if you make a conditional distribution and they are different, there's a notable difference between the way things are, then we would say that there is a relationship. Now, you might be thinking, what the heck is this conditional distribution? Well, we're going to go make some in this kind of example down here. So let's go check this out. So first off, we have that two-way table. And I was supposed to have erased this, but my bad. We'll put that back in a second. I pretended to take a random sample of people from Huntingtown High School, and they are displayed in this table. And you'll notice that over here, it is broken up into pizza places. And so this is their favorite pizza place. Pizza place. Calvert County, there are not very many options. I wish there was like a New York styled pizza. I don't know, that was down here, just a little bit more authentic, but whatever. And then over on the side over here, we've got a gender. So let's see if we can answer some questions about this, make sure that we're all good. It says the row variable for us is gender. And then the column variable is favorite pizza place. Yay. It says, what is the marginal distribution for favorite pizza place? It says the marginal distribution for favorite pizza place is on the bottom, and then it's asking us to figure out what it is. And since we're here, we're just going to find out the marginal distributions for everything, because I think that would just go well. So really quickly, 4 plus 8 is 12. 7 plus 2 is 9. 9 plus 5 is 14, and 15. Awesome. And then if we add across the other way, 4 plus 2 is 6. 6 plus 9. I know you don't need to listen to me jabber, but it's fine. This comes out to be 25, right? Am I being unintelligent? No, that's right. Okay. Then if we add up the other ones, this is 25. And then if you add it across the board, a good way to check yourself is actually do make sure they add to the same thing. And they should. So I'm just going to double check. And they do. Oh my gosh. So I asked 50 people, and this was kind of our distribution. So it asked for us to talk about the marginal distribution for favorite pizza place. But we know that that's on the bottom, and that is all of these numbers. So you can see the way that the pizza is split up, but distributions always have a total or as a collection of all things. So you can kind of see that. So this would be 12, 9, 14, 15, and 50. Now, if it asked for the distribution or marginal distribution of gender, well, that would just be over here, 25, 25, and 50. Awesome. So just to practice a little bit more, it says what percent of those who like Papa John are male? So of those who like Papa John's. So those are the only people we care about. And so if we look, we see the people that like Papa John's. How many of those are there? Kind of skimming across here, I see that there are 14 people that like Papa John's. So out of those 14, how many of them were male? Well, there's only 9 out of the 14 that work there. So we've got 9 divided by 14 is a number 0.6429. And so if we change that to percent, it would be about 64.29% are male. All right, this says what percent of males prefer Papa John's? Well, that means I only care to look at the male group here. So of the males, there appears to be 25. So I know that that's going to go on the bottom. How many of them preferred Papa John's? Only 9 out of the 25 did. So now we've got something looking like that. 9 divided by 25 is 0.36. And so we could say 36% of males preferred Papa John's. Okay, so today we are going to just kind of pose our own question. This is one of the times where picking like an explanatory variable or response variable is really up to what your preference, right? So I'm going to ask, does gender, and I'm making gender my explanatory variable, does gender explain or predict your favorite pizza place? That's my question. And now I'm making this my explanatory variable and this my response. Awesome. Whenever you are looking to answer some of these questions and determine if there is a relationship, we are going to use the conditional distributions to help us with that. Now, the conditional distribution is always based off of the explanatory variable. So, does gender explain or predict pizza place? The condition that we're going to break it up into is male and female. And so we're going to look at a distribution for just the males. And we're going to look at a distribution for just the females. So we're going to look at Lido's. We're going to look at Mama Lucia's, Papa John's, and Domino's. We're going to do the same thing for our girl squad. Oh my gosh, I'm going to run out of room. Okay, that's really bad. Okay. Oh, dear Lord. It's fine. It's going to be fine. Okay, so from here, we're going to make our conditional distributions. So we're going to say, all right, given that we have males, how many males did we have? We had 25. So out of the 25, how many of them like Lido's? 4. Out of the 25, how many liked Mama Lucia's? 2. Out of the 25 males, 9 liked Papa John's. And out of the 25 males, 10 liked Domino's. We'll do the same thing for females, just kind of breaking it up here. So we can say 8 out of 25 were there. 7 out of 25 were for Mama Lucia's. 5 out of 25 liked Papa John's. And out of the women, only 5 liked Domino's. So the reason that we break this up is because, well, actually in this case, this was kind of dumb for me to make these the same amount. So that's kind of dumb. But for the most part, when you collect data, a lot of times these numbers won't be the same. And so you won't be able to just make comparisons across these numbers, right? And even in last unit, we talked about standardizing things or making things easier to see. Well, turning all of these things into percents and talking about them is a way of like kind of standardizing things and making it easier for you to make a comparison. right? Just like we found those z-scores and it led to, you know, the areas and all that stuff. So here we're going to do the same thing. And we're going to turn all of these to percents because it's going to help us have a little bit better of an understanding for what we're looking at and being able to make a comparison. So let's do 4 out of 25 is 16%. 2 out of 25 is 0.8, which would be 8%. 9 out of 25 would be 0.36, which would be 36%. And 10 out of 25 would be 0.4, which is 40%. And all of these things should add to be 100 because we're talking about 100% of the males. So up here when I was talking about like, hey, percent should meet the condition, right? Like we were looking at the condition that they were male. And notice that the denominators were the same on all of these because we're just looking at the males, right? And all of these percents should add up to 100 because we're talking about 100% of the males. That's what this is talking about. Okay, so we need to make the conditional distribution for these ladies over here. So let's do the same thing. We have 8 out of 25 is 0.32, which is 32%. 7 out of 25 is 0.28, which is 28%. 5 out of 25 is 20%. And again, if you were to add all of these up, 20 plus 20 plus 28 plus 32, that does come out to be 100 because we're talking about 100% of the females. And this was how many females we had. So now that we have these distributions, we can go and talk about if there's a relationship between them or not. Now, the way we would know is if conditional distributions are similar, they all look, everything, the biggest is the same, the smallest is the same, the numbers are comparable, then we'd say there's nothing between them. But if the conditional distributions are different in the way that they're set up, there definitely is a relationship between those. So it says, is there association between the variables? When I look at this, for males, it appears that the lowest percents for males are Litos and Mama Lucias, and the higher ones are for Dominoes and Pop Johns, versus the lower ones for this one are Dominoes and Litos, and the higher ones for the females are Litos and Mama Lucias. So there actually is a difference between those. Have I proven it? No, but I notice it, and so I'm going to say I notice a relationship or a trend.